Hi, hello to everyone. This is Dr. Satheesh Kumar. Working as an associate professor in the Department of Information Technology at the Institute of Aeronautical Engineering, Hyderabad. So welcome back to the session in optimal decision in games in artificial intelligence. So continuation of the section. The next two topics is we are going to learn about the alpha beta pruning algorithm in artificial intelligence. Okay, so in the previous section, just I have said about the min-max algorithm, how the min-max algorithm you are going to be apply in the given trees. Okay, how we are going to find each and every node values using min-max concepts. In the min-max concept, we have to use depth first search and algorithm and backtracking algorithm. Okay, so in that min-max algorithm, just we have to visit all the presented node for finding the value of each and node values. Okay, so if it is so, the time complexity is space complexity is more. Okay, so it is the drawback of the min-max algorithm. So overcome this algorithm, overcome that drawbacks. Just we are going to use the alpha beta pruning to design the games in artificial intelligence. Let us start. Okay, the first just I am going to tell what is alpha beta pruning in artificial intelligence. We are going to overcome the drawback of your min-max algorithm and all, and I will tell the concept of alpha beta pruning, how it will be work to selecting the best moving for playing the chess or some other games. Okay, with the example, just I will tell you. So the first, what is alpha beta pruning? Okay, so it is a modified version of your min-max algorithm. Okay, so this one is a modified version of your min-max algorithm because just we are going to overcome the drawback of your min-max algorithm. Okay, it is an optimization technique for the min-max algorithm. So why you are telling that optimization technique, it will produce the best result. Okay, it will produce the best way of moving while you are playing the game in that using alpha beta pruning concepts. Okay, so that's the way just we are going to tell that it is an optimization technique in min-max algorithm is alpha beta pruning. Okay, as we have seen in the min-max search algorithm that the number of game state that has been examined or more exponential in depth of the given tree. Right. So here, since we cannot eliminate the exponent, okay. So in min-max algorithm, just we can't delete, we cannot ignore any present nodes. Okay, but we can cut off into the halves. Okay, just based on your alpha beta pruning, just we are going to cut off your tree. Okay, just for terminating the worst cases. To become a best case, just we are going to use the alpha beta pruning. Okay, hence there is a technique by which without checking each and every node the game tree, we can compute the corresponding min-max decision, and the technique is called the pruning. Okay, so what the pruning here, just without checking present node in your tree, just we are going to compute all the min-max values of your node. Okay, that's called as a pruning. Okay, the next one is this involves two threshold parameters, that is alpha and beta. Okay, here just we are going to use two parameters, especially in the min-max algorithm. Just we are going to use two parameters. The name is alpha and beta for future expansions. Okay, it's also called as alpha beta pruning. It is also called as alpha beta algorithm. Okay, so always just we are telling that alpha beta pruning in min-max algorithm. Here just we will call it as alpha beta algorithm. Okay, so alpha beta pruning can be applied any depth of the tree, and sometimes it's not only a pruning the tree leaves but also entire subtrees. Okay, so when it is not applicable of that path or move, just we are going to neglect. We are going to omit. Okay. So this method plays a great role reducing the number of nodes which are found out the min-max algorithm. Okay, min-max algorithm just we have to visit each and every nodes. Okay, so if you are using the alpha beta algorithm, we no need to move to all the nodes. Just we can neglect the particular moves. Okay, so when one chance or options are found the minimum, it stops assessing a move. Okay, when we'll get the chance to neglect that particular node using the backtracking, just we can stop the accessing the particular nodes, right? So that's the concept of alpha beta pruning. This method is also help to improve the search procedure in effective way. Okay, if it is so, it will comes under the best case. Okay, the space and time complexity will also is very less. Okay, like this alpha beta pruning will work in the is in the game. So visit each and every node in your tree. Okay, the next one, the two parameter can be defined. Okay, already I said the two parameters, two default parameters in min-max algorithm, that is alpha and beta. Okay, so how that alpha and beta will work in your algorithm, in your specific problems, and how it will be assigning the values. Okay, that I will tell you. Okay, so the first one is alpha. So alpha, the best highest value just we are going to assign. Okay, just we are going to choose the highest value of in alpha value. Choose we have found so far any point along with the path of maximizer. Okay, so here the initial value of this alpha is minus infinitive. Minus infinitive, just we can calculate or we can compute based on this statement only. Okay, the initial value just we are going to consider for the alpha is the minus infinitive. Okay, from the highest value. Okay, the next one is a beta. Okay, the best lowest value just we are going to assign the beta. Okay, so here the choice we have found so far, any point along with the path of the minimizer, the initial value of the beta is plus infinitive. Okay, the most of the value. Okay, optimal value just we are going to assign the beta. If it is so, alpha will always work as the maximum value. That is the highest value. Okay, max. The beta is always work as a minimum algorithm. This is a minimax value. Okay, that is the lowest value. Okay, so here the value, the initial value only just you are going to assign the minus infinitive for alpha plus infinitive for the beta. Okay, so the alpha beta pruning to standard min-max algorithm returns to the same move on the standard algorithm does. Okay, so what the min-max algorithm will does all the procedure the same way, just we are going to follow. But one more additional concept, when is the chances will come to omit or we stop the accessing the nodes, that time we will neglect, we will omit all the nodes present in the tree. Okay, but it removes all the nodes when we really affecting the final decision, right? So based on the making algorithm, hence pruning this node, it makes the algorithm fast. Okay, if it is so, just if you are stopping accessing the particular nodes, the algorithm will work fast to find the value, all the value of your unpresented nodes in your tree. Okay, so this is the important concept of the alpha beta pruning of the alpha beta values, how we are going to assign while calculating or designing the game tree. Okay, so now just we are going going to see about the condition for the alpha beta brooding. Okay, so what is the condition? While you are calculating the value, okay, when we'll get the chance to stop the accessing the nodes, that time just we have to see that the alpha is greater than or equal to beta. The value of alpha is must be the greater than or equal to beta. Okay, so this one just you have to keep in your mind while you are accessing all the node to find the value of each and every node. Okay, so here just we have to keep in additional points. The key points about the alpha beta pruning is while you are accessing all the nodes in your tree to find the values. Okay, the max player will only update the value of alpha. Here I said, right, alpha will work under the max values because it is the highest value, right? So beta will always work under the minimum value, minimum value, because it is having the lowest value. So like this, here the max player will only update the value of alpha. Okay, then again the minimum player will only update the value of beta. The minimum value only update the value of beta, right? So now while backtracking the tree, the node value will be passed upper node of instant of value of alpha and beta. Okay, based on this alpha and beta, the condition of the max player and minimum player, we are going to update the values using the backtracking concepts. Here also just I said the same procedure we are going to follow. Okay, in alpha beta pruning also same, the depth first search also the same, backtracking algorithm also we are going to use. Okay, so we will only pass the alpha beta values to the child node. Okay, so the final just we are going to see one example betterment of your understanding. Okay, so all the here already said this one is here terminals. Okay, so this one is here utility, right? So everyone knows that this one is a terminal, this one is a terminal, this one the value is a utility, right? So here just we are going to find the value of each and every node based on your utility values, right? So what is the root node? The first to move. The root node is the starting the first to move. Okay, if it is so that condition, that procedure, we have to follow the maximum algorithm. Okay, so the max. Okay, so here just we have to use the max. The next one is procedure is minimum, then maximum, then minimum. Like this, just we have to fix first of each and every node conditions. Okay, now the first step, just we have to use the some depth first search algorithm to starting the moves from the down to top. Okay, to calculating all the value. Okay, now the your player is in the in this state terminals. Okay, so now this terminal just we are going to find the value of this beta. Okay, so this node. Okay, so here what is the concept here? A minimum. Okay, so what is the concept of this entire node is a minimum concept. Okay, now just we are going to calculate the minimum value of your terminals. Okay, so here what is the minimum value? So 3. So here 3 is here just a minimum value. So here now we are update the beta value as 3, right? So from this node just we are going to take the minimum value. Okay, now again just this alpha value also we are going to assign as a 3, because here the greater than or equal to 3, just we have to keep that condition. Okay, now just we have to move to this node. Okay, so here also the minimum node beta value we are going to find as a minimum. So 1 is the minimum value of your beta, right? Here just we are going to compute both node value and alpha beta value based on your min max concepts. Okay, now just we have to move to the is a backtracking. Here again we have to come to the this node. Okay, here alpha. Okay, so already we have just you assign the value for alpha is 3. Now we have to modify. We have to update the value of this alpha, maybe or may not be. Okay, now what is this node procedure? It is a maximum. Okay, now maximum. Now just we have to take the maximum value of from this 2 child node. Okay, so 3 and 1. So what is the maximum value? 3. So 3. The same value. Now the alpha value is 3. The same value we are going to assign for this alpha. Okay, so like this again just we have to move to the parallel node. Next step just we have to move to the parallel node of this tree. Okay, so now we have to move to the again we are going to use some depth first search to come down the that available terminals. Now we are going to find the value of this one. Okay, so what is the value? What is the condition of this one? The minimum. Okay, so this node is have to follow the minimum concept. Okay, so what is the value of minimum? What are the terminals? 2 terminals here. What is the value of terminals? 7 and 8. What is the value of minimum? 7. Now the beta value is 7. Okay, the next node. So what is the minimum value? 9. Okay, so now just we have to move to the backtracking concepts. Then you have to find this node value. So here what is the value of what is the condition of this node? Maximum. So alpha value is always just we have to find the maximum 9 here also and 9. Okay, then just we are going to one more concept here. Just we are going to stop the accessing the and nodes. Okay, so here after finding this value maximum value 3. Okay, this steps we are going to neglect. We are going to stop the access these nodes. Just we have to omit these nodes to visiting again. Okay, so now just we are going to move to the here. Okay, so here what is the value of beta? Just we are going to have to compute. So what is the condition here? The minimum. So from this one, just which one is a minimum value? 3 and 9. So here 3 is the the minimum. So this node value is 3, right? So here now the player is here. So now we are going to the parallel node, a parallel node. So here also again just we are going to use some depth first search algorithm. Just we have to come down. Okay, here also two terminals are there. The terminals utility values are 2 and 11. So minimum here what is the condition? It's a minimum 2. So beta value is always 2. Okay, then again here 1 and 12. 1. Beta value is 1. Okay, now again we have to come. This is a parallel node also, right? Then 14 and 9. What is the minimum value? 9. So beta value is 9. Again you have to come to here. This one. What is the minimum value? 13. Here beta value is 13. Right? So next one, just we have to come to the backtracking of this node to find the alpha value. So what if you find the alpha value? What is the condition? Maximum value. So what is the maximum value of these both the nodes? 2 and 1. So what is the maximum value? 2. So alpha value is also 2. Again you have to come to here, the parallel node, 9 and 13. What is the maximum value? 13. So alpha value is 13. Okay, again just we have to use the backtracking. We have to move to this node. Okay, then what is the beta value? Beta value is a minimum. Already said always a beta value is a minimum, alpha value is a maximum. So beta value is a minimum. So minimum, what is the minimum value? 2 based on your values 2 and 13. Just 2 we have to keep. Okay, so 2 just we have to find the next root node value. Again just we are going to the backtracking. Okay, so here what is the condition of this one? The maximum. Okay, so this root node we have in the maximum value. Okay, so it is the maximum value means what is the maximum value of this compared to this node? 3. Okay, so what is the alpha value here? 3. So now the just the player will select the moving from the root node to next node is the beta. Okay, so this way only. Okay, totally this way we are not going to select. So entire this the right side node will be stop the access by the players using the alpha beta pruning. Okay, now just entire it will search the this way only. It will play the left side only. Okay, no need of visit this here. Okay, so if it is so, the here the space complexity and time complexity is very less. The moving of the finding the value of all the nodes is very fast. The algorithm will work is a very fast manner. Okay, so this way just we are going to use this concept alpha beta pruning algorithm to find all the nodes of value in the same as the min-max algorithm. Clear? Okay, so this is some textbook that I have used to collect all the information regarding your alpha beta pruning. Okay, so some reference also just given to go through these values. Okay, if you are having any doubts, just you can post in your comment box. Just I will clarify you. So we will meet you in the next session with the new concepts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.